Now let's talk about some failure scenarios, as in what happens if something were to go wrong. So I've taken this picture from the DataStax documentation, and they've done a fairly awesome job in terms of explaining how this is going to work in 4.0. So there's something called as transient replicas, right? And the way it works is if your replication factor is equal to 3, you can say that, as you can see in the picture to the top right, there are two replicas which are colored green and one replica is colored blue. That blue is called as a transient replica. And the way transient replication is designed to work is during the normal course of writing data or inserting data, right, we are not going to send the data to the transient replica at all. We are going to send it to the actual replicas or the full replicas, right? Now, in case a replica were to go down, right, a full replica were to go down, then the transient replica will receive the data and not otherwise. So the way it's going to work is incremental repair and read path, something that we are going to talk about soon. One thing we have to keep in mind is the whole notion of building these repairs and having this read repair, blocking read repair, etc., and the notion of transient replica is to try and see if Cassandra can move towards immediate consistency as much as possible under many circumstances, right? That's the whole idea, right? So look at what it's going to do. Incremental repair will be used to clean up the transient data at transient replicas and propagate it to the full replica when the full replica comes up. Incremental repair occurs, transient replicas stream out the transient data, right? Anti-compaction, etc. Don't worry about that, right? That can happen as well. The read path must always include at least one full replica. That's a very interesting change, and can include as many replicas, transient or full, doesn't matter, necessary to achieve the desired consistency level, right? So it's essentially saying is you must have at least one full replica to read from, and then on top of that you can choose whatever you want. At least one full replica is required in order to provide the data not available at transient replicas, but doesn't matter which full replica is picked, because incremental repair makes sure that the data sets across full replicas is exactly the same. So it doesn't matter which full replica you read from, you're guaranteed to get the data. Reads at transient replicas are faster because obviously transient replicas will store a less amount of data, right? But there are some downsides to that as well. These are some of the changes that are actually coming through. So how do you modify your key space definition to specify transient replication? And this is how you do it. So you can say either create key space, or you can do alter key space, doesn't really matter. And instead of specifying just one number, replication factor, you say slash another number. So total number of replicas is 3 in this case, one being the transient replica, right? So this is essentially what you can do to take advantage of transient replication, and this will be particularly applicable in version 4.0 in Cassandra. The other thing is there are some operational aspects that you need to keep in mind. And one of the key aspects is it's also a good idea to run a small number of vnodes with transient replication, so that when a node goes down, the load is spread out to several other nodes that transiently replicate that range. So if you remember the conversation of vnodes, and we said that the good number is between 4 and 32, and the general number seems to be either 8 or 16. So that's basically the whole idea, right? To have the replication to a small number of vnodes. The other thing that I want to talk about is something called as each quorum. And let's look at this, from a practicality perspective. Imagine if you have two data centers, right? And you have data center 1 and data center 2, and both are geographically, spread out. They're quite far out. Now what will end up happening is, if your replication factor, let's say, is greater than 1 in the other region, and if the coordinator chose to send the data, let's say 50 MB worth of data, partition size, to the three nodes individually, then you are essentially transferring 150 MB of data from data center 1 to data center 2. This coordinator, let's assume, is sending 50 MB data here, 50 MB of data here, 50 MB of data here. That doesn't make any sense. So what happens is, there is something called as a remote coordinator. Right, again, this is not a special node. This is chosen on the fly by the coordinator here. The objective is, I transmit the data one time. So instead of 150 MB worth of data, I transmit only 50 MB of worth of data. And this node acts as a remote coordinator which does what it does. And then it essentially responds back saying that, hey, you know what, job done. This is an optimization which Cassandra can do internally. Now, these are some of the ways in which Cassandra tries to, limit the data that is transmitted across the wire, right, for deployment topologies, which basically have geographically disparate data center implementations.